Hey guys, it's Ben, and today I'm going to be walking through Overpass to Hacked, Try Hack Me box. So this was a bit of a different one. This wasn't like a regular boot to root. It involves, first of all, some forensics. You've got a pcap file, and you have to analyze an attack which has been made against this theoretical company, and then you sort of have to take those steps or use what the hacker has used to gain access yourself and gain privilege escalate to root. So I suppose let's just get on with it. We'll download the task files, and I've got a terminal set up. What I'll do, I'll just make directory files, and I'll also make a directory over here. I can't type in that one for some reason. Make directory notes, right? And which one? There we go. I'll split that up again. Perfect. I'll cd into the files one, and what I'll do is I'll copy. Actually, I'll just move it from downloads overpass 2.pcapng. That was the file, and we'll move it into this directory. We've got this pcap file here, so we can open up Wireshark and have a look. So I'll just open up this one here. So the first flag it asks you to find is what is the URL of the page they used to upload a reverse shell. So we've got this this pcap file. We've got all the packets. It's quite a lot. It's quite massive. We can see there's some HTTP requests here. So at first I thought let's just filter out by HTTP and see what is the HTTP. So we can see that this hacker has first of all made a get request to this development directory, and then from there he's made a post request on upload.php, and he's supplying PHP, and then from there he actually makes a get request to uploads /payload.php. So perhaps he's uploaded this payload.php file. This payload.php file includes a reverse shell. So we can actually click on this to look in a bit more detail, and we can open this up, and we can see there is some sort of reverse shell here. You can sort of see, look, it's using exec or exec. I don't know how you pronounce that, but it's like a system call in PHP, and then he's calling that here. I'm just going to copy printable text and go back to here. Just make a vi. I want to cd into notes, and vi payload.php. What I'll do is I'll paste this in here. I'll also cut out everything we don't really need. So that's this stuff. We've got the PHP code there, and I'll just get rid of all of this stuff, the nonsense. So we can see, look, this is just a basic reverse shell in PHP. We've got it in this file now. This is this payload.php, and from here we can see that the directory it uploaded to was development. So we should be able to get a few flags here. So what's the URL page they used to upload a reverse shell /development? What payload did the attacker use? We've got the payload, and then it asks what payload does the attacker use to privesc. So if you go back and analyze this payload, right, I've got it in here. So let me cat out payload. We can see the reverse shell is actually using netcat, and it's calling back to port 4242. We can open Wireshark again, get rid of this filter. Now I'm going to filter for TCP port 4242, like so. And we've got some TCP packets going back and forth. To actually follow this, I'm going to right click and go follow TCP stream, and we see we've got the whole TCP stream, the whole communication between the box. I'm now going to create vi reverse rev shell revshell underscore commands.txt. I'm just going to paste this in here, and we can sort of go through this manually and have a look, see what he's actually doing right, or he or she, the hacker's doing. So he starts off by importing pty and getting like a bit more of an interactive shell. He's then using ls.la to list out the files and the hidden ones. He's found this overpass hidden file, catted it out, and I'm not sure what this is. Perhaps this is a hash of some sort, or encoded or encrypted data. He then privilege escalates and uses su to change user to James. He then enters this password whenever not art instant. He then changes directory. As James, he looks at his sudo privileges, like what commands he can run as sudo, and he can run all. So knowing that, he can cat out with sudo without a password. He can cat out the etc shadow file, which has the password hashes. So we found quite a lot of useful stuff from here already. He then installs this SSH backdoor from this GitHub repository, and then he sort of sets this SSH backdoor up with what looks like a hash here. He makes it executable before doing that, and he also generates a public and private key. So I'm going to cat out revshell commands and sort of extract the useful stuff. So vi useful.txt, the stuff which would be helpful when we're going through this again. So we've got these users down here. What I'm going to do is I'll just copy all of their hashes and their username. So we've got that there. Got the users. What else do we have? There's this password for James we could possibly use. So I'll go down. James, there you go, past this, and then there's also this SSH backdoor. I'm not sure. We can investigate this GitHub repository and see what this is, I guess. I think that's about it. And there's also this hash here, which is used when it's calling this backdoor. The backdoor is in this repository, so I'll take a note of this hash because it may come in use. I'm also going to I've had this issue and it then stops me like clicking up here. It's a bit of a shame. What I'll do is I'll quickly restart this. I think it's Wireshark which is causing the issue. What I'll do is I'll close down Wireshark. I'll quickly restart my VM. Let me just write here. Clear. Quickly restart my VM. Get back on. Take a second. There we go. Log back on. Hopefully, for some reason, Wireshark causes my screen to freeze and I can't really fix it unless I restart. I'm going to cd, I'll do that for all of these. I'll cd into desktop, try hack me, overpass 2 hacked. There we go. So I'm back where I was. I'll get rid of my group terminals. So let's just cut out useful, see what we've got so far. There's these hashes, so perhaps you may want to crack these hashes. So I will do that. I'll just go vi hashes.txt just so we get these users hashes cracked. And let's go back to the flag board, see what we've got so far. So what is the password the attacker used to privesc? That was where he privilege escalated to James, and that is whenever not instant, like I said earlier. How does the attacker establish persistence? They use this GitHub repository, which they used to install a SSH backdoor. Using the fast track word list, how many system passwords are crackable? So we've got these system Unix hashes here. We can use this fast track word list to try crack them. I've got them written in this word list hashes, so I can just go John hashes and then specify the word list here, word list equals, there you go. We do that, and that did not run. I expect, because perhaps I've done this before, if I go like this, for example, would it show me? Hashes show. Yeah, it's saved, it's cached basically. When I originally run this command, it returns 4 hashes you could crack using this fast track word list. So I've done that. Research, analyze the code. So it says what is the default hash for the backdoor and what is the hard-coded salt for the backdoor. So we can see we've supplied a hash here for this backdoor. We've also got the link to the GitHub repository, so it's definitely a good idea to have a look at this yourself and see how does this work. If you go onto main.go and look at like the script, there's this hard-coded hash string which is used. So that's one of the flags. That's the what is the default hash for the backdoor. And there's also down here it takes in a salt, and when it uses this verify pass function. If you look at verify pass, it takes in a hash and a salt. The second parameter is this 1236, and that's passed into this verified pass as a salt. So it's definitely a good idea. You can take the indication that this part here is your salt, and that would be correct. However, we found the default hash and the hard-coded salt for this backdoor SSH binary, right? But if you look at the command he ran, and I'll quickly cd into files, or is it in here? Nope. Cd into notes. If we cut out rev shell commands, just to show you again, he doesn't actually use the default hash. He uses this 60 blah blah blah. So he uses his own hash as a way to authenticate. He'll use that hard-coded salt because it's hard-coded into the program, but he will use his own password basically to authenticate. What we can do is we can look back up here and we can see it imports. We'll see the function where it actually hashes it. Verify pass. So yeah, when it verifies pass, it hashes the password and the salt. This function hash password shows it's using the SHA-512. The SHA-512 hash algorithm. So what we can do is we can actually try crack this. We've got the hard-coded salt. We can brute force the passwords. So what I'll do is I'll go vi ssh hash.txt. I will first of all paste this the hash which was used and insert. There we go. And I'll do a colon, and then what follows will be the salt, which is hard coded into the program. We can get that from here. So like so. And there we go. I'm going to right click. I actually used hashcat to crack this. If you go up, for example, hashcat, and we'll go on their website. You can look around. It specifies the different ones. We know it's SHA-512. There's a salt, so it could be this one. It could be this one. And it doesn't actually show the numbers for them there. Hashcat example hashes. There we go. This one will have it. So there's the SHA-512, so we know this is going to be TAC M710, 1710, or 1720. We're going to use a wordless mode, so hashcat TAC A0 for wordless mode, TAC M. Let's start off with 1710. We'll supply the SSH hash here, .txt, and we'll specify the word list, and rockq.txt, and we'll run this and see if this runs. So it looks like it's also cached it. If I go tac show, so it shows, because I've previously run this command, the correct password is November 16. So this is the password used for this SSH backdoor. So I can go in here, I can vi useful, and I'll insert. There we go. So that's the password used for the SSH backdoor, and we've got that fine. If you go back to the challenge, it asks you what's the hash the attacker used. That's this one here. This tag A supplies the hash, or we've got it here in our useful info, and the password cracking with RockQ gets November 16. So we actually have to get back in now. So what I'm going to do is I'm going to first of all cd desktop try hack me sudo open connect to the VPN like so. I'm connected to the VPN now. I can do some initial scanning and see what services are open. The good thing about this challenge is we already know some routes as we've analysed what the attacker has done. Right, they've set up this SSH service, and it's actually on port 222. That's also hard coded into the script. It sets up the service on. Try find the command for it on port 222. So we know this Ethernet, this service here is SSH. It's also got the website like so. So if we go back to the website, HTTP like so, and we've got this hacked by Kutus clan, right? That's another one of the flags. The attacker defaced the website. What message did they leave as a heading? So we've got that flag. We know this is the port used. So what we can do is SSH on. If we look back, where am I going? I'll move that one down here. I'll move up here. Clear. Yeah, cut out shell commands. The user which generated this, like the file and generated this service, is James. So we can go SSH James. The IP is this. The port is 2222, and we'll just try this. And we know the password is November 16. We get this error saying no host key type, so we can sort of find out what is going on with this. We can search up this error. And we can see if we can find a way around this. If we see there's this tag you can add in, and this will bypass this and get rid of this error. So I'll do that like so. Bypass, and we go yes, and then we've got, it asks us for the password. We know the password, that is November 16, and we've got initial access, right? We are we are James now. We can go back one. We can cut out the user.txt. We've got the user.txt flag. If you remember back, it says he's got sudo privileges. He can run all as all. So perhaps if we go sudo tac l, we're asked to enter the password. If we enter this one here, right, let's just go and copy this cat useful.txt. If we copy this password here to see if he's still got this privilege, we see no, that password no longer works. So James has obviously changed his password. It's not going to be as easy as that. If we just ls-la, we see there's this .suid bash binary. It's owned by root, so that means when we run it, we'll have the privileges of root, and it looks kind of sus, right? We don't know what this is. If you go file .suid_bash, right, we can see it's an elf binary. We don't know much. You can play around with it. You can try, let's execute it, suid_bash, and it seems to sort of pop a bash shell. If you go ID, it's James. So what I did is just played around with this. How can I exit this? There we go. I did tac help, and then we can see, look, this is the actual bash binary. This is the bash binary. So what I went to do, we got suid permissions on this. We know what the binary is. So you went to GTFO bins, searching bash here. If we got suid permissions, you can do this tac p, and hopefully that will add us to root, or at least change your permissions. What I'll do one more time just to show you. If I go ID, you can see our groups there. There's no high privilege group. If I did this alone, so it'd bash. If I did ID, you can see there's no high privilege groups. If I exit this and then do the tacp command, you say who am I, you root now. So if you do ID, it still says you've got like some of James's user, but you also have privileges, so you can cd into root and cat out the root.txt. That is the challenge done. You've got all the flags, and yeah, I hope you've enjoyed.